Next problem is called diameter of binary tree. We are given the root of binary tree and we have to return the length of the diameter of the tree. The diameter of binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges, not the number of nodes between them. So in example 1, we see that basically the most distant nodes are the nodes 4 and 5 when compared to the node in the right subtree 3. So we have 3 edges between them. So the total diameter is 3. And if we do the same for 5, we will have 5 to 2, 2 to 1, and then 1 to 3, which is basically the length of 3 edges, and that's the diameter of the tree. One interesting example would be if we had, for example, a diameter that doesn't pass through the tree. So, for example, this is a large diameter, but it's not the largest because from this node up here and this node here, we have the longest number of edges. Let's just add one more. Basically, the concept is that the diameter doesn't pass through the root; it passes through its left child. So that's one thing. How to solve this problem? Well, when we have these calculations, diameter, the distance between the nodes, one of the most useful things is the height of the tree. And we already know how to recursively calculate the height of the binary tree. And basically, in this case, we will just be tracking the maximum difference between the left and the right subtree. So, for example, if we have a node here, and we will get the when we are calculating the maximum height for this node, we will get the left calculation for the left subtree will be 2, calculation for the right subtree will be 2, and then we will say, okay, the maximum height is basically 3 because we're also counting this node. But before we do that, we will just do the calculation for the diameter. We will see if we can update the maximum diameter that we have so far recorded. And basically how we do that, we will just add 2 and 2. I will just add the height for the left subtree and the right subtree, and that will match the number of edges that we have. So we have 1 edge, 2 edge, 3 edges, and 4 edges between this node and this node here, these leaf nodes that we have here in this binary tree. So basically that's the only thing that we have to do to calculate the diameter. So first we will create a diameter class, which will only have one field called value. And we will see in a second why we are creating a separate class that will only contain one int value. So basically we will just declare our max diameter to be a diameter of value 0. And then we will call our helper function passing the max diameter and also the current root. Finally, we will just return the value that we have recorded while traversing the binary tree. We are creating the class because we want to pass the value to all the helper, to all recursive calls from the helper function by reference. So we want the value to be changed in any deep down in the recursion tree call of the helper function. If you pass it just by value, basically we will have copying of the parameter each time, and we will not be changing the diameter defined inside the main function diameter of the binary tree. One other possible way to do this is basically just to create an int value inside the scope of the class solution, and then let it behave as a global value. But passing by reference might be more like not readable, but basically an indication of what we are trying to do. Next, we will define our helper function. The base case is always for binary tree is just checking if the root is equal to null. Height of empty tree is 0, so we just return 0. Then we recursively calculate the height for left and right, as we always did, and then we check if we can update the maximum diameter so far. We just check by adding up the left and right subtree height and checking if the current value that we have stored in the max diameter variable. After that, we just return the maximum height for the current node, which is the maximum height of left or right, basically the larger height of left or right subtree plus 1 accounting for the current node. as we said for the calculating the balance, if the tree is balanced binary tree, and also calculating the maximum height of a tree, we have a linear space and time complexity proportional to the number of nodes.